Sometimes you can get rid of the quadratic formula for a particular ice chart. It doesn't always work, but sometimes, especially if you have a very small or very large value of the equilibrium constant, sometimes that'll work to your advantage where you don't have to do the quadratic formula. You can do the quadratic formula and get the correct answer. So here's a reaction between ammonia reacting with water to make the ammonium cation and the hydroxide anion. And let's say that we start a reaction with zero point 0.3 moles per liter of ammonia. Water is a pure liquid, and pure liquids do not appear in K. Therefore, we can cross that out of this column. We don't need the concentration of water because it doesn't show up in the K. If our ice chart is started with just 0.3 moles per liter of ammonia and 0 on the product side, then we know the product side has to increase and the reactant side has to decrease. All of the coefficients are 1, so we're going to lose 1x on the left and gain an x on the right. At equilibrium, we'll have 0.3 minus x, and x. Next, we would plug into our value of Kc. 1.76 times 10 to the negative fifth would equal products divided by reactants. The product is x squared, reactant 0.3 minus x. If you know that this very small value of K means the reaction favors the reactant side, that means we started this reaction with all reactants. We had 0 products. The amount of products we're going to make is very small. So 0.3 is a relatively large number compared to this x. And we can use that to our advantage to make the math easier by making an assumption. The assumption is going to be that x is negligible compared to 0.3. That'll make our denominator, instead of 0.3 minus x, simply 0.3. The numerator is still x squared. This is a lot easier of an equation to solve because I can get x squared by itself by cross multiplying. So I bring the 0.3 over to the left. And now I can take the square root of both sides and get x by itself. And I don't have to worry about the negative value for x because x can't be negative according to the ice chart. And I get an answer for x, 2.3 times 10 to the negative 3. That came from making an assumption, and the only time the assumption is valid is if this quantity that we're either adding or subtracting that we're going to neglect is less than 5% of the number that we subtracted it from. So in this case, if we check that, our x value was 2.3 times 10 to the negative 3. To figure out what percentage that is of 0.3, we just divide it, put 0.3 in the denominator, multiply by 100%. That'll give us our percentage, and this percentage is less than 1%. So the assumption is valid if we get an answer that's less than 5%. Now we could have solved this equation with the quadratic formula, but we would have gotten approximately that same answer for x because the assumption was valid.